So today we move into some of the intro algebra part of the course. First thing we're going to talk about is variables and expressions. That's going to be the concept of today. So what are variables? Variables are basically symbols used to represent numbers and values, as it states in this sentence here. Variable can be most commonly seen in algebra as something like x. Could be like a y, any kind of letter. If you really wanted to, you could use a triangle as a variable. You could use a smiley face as a variable. You could use anything you want. It's just a symbol used to represent numbers or values. Algebraic expressions, as it states, is a mathematical segment consisting of additions, subtractions, multiplications, and divisions of numbers and variables grouped together. So let me give you a couple examples of an expression. 3x plus 5 is a case where I have numbers and variables multiplied together, added to another number. I could have something like 5x squared plus 3xy plus z, something like that. Those are numbers and variables added, subtracted, and multiplied together. An example of a term in an expression is a number, variable, or a product of quotients of numbers and variables. So for instance, in this above expression, 5x squared is one term in that expression. Z is another term in that expression. 3xy is another term in that expression. So this expression has three terms within it. So if we talk about factors in terms of being items being multiplied together in an expression, something like this, 5xy squared. 5 is a factor. X is a factor. Y squared is a factor of this term here because they are specific terms within the multiplied term. When we move to talking about exponents, we talk about how many times a base number is multiplied by itself. So in this case, x functions as what we call a base, and our exponent tells us how many times we multiply that base by itself. So if I had something like 2 to the third, that means take the base of 2 and multiply it by itself 3 times. So the next thing we're going to do is we're going to take a look at some mathematical operation and their written word translations. So if I want to say addition, there's a number of ways to say that, and you can read the chart. Subtraction, number of ways to say that. Multiplication, number of ways to say that. And division, number of ways to say that. Where I find a lot of people don't get the correlation between is difference. People oftentimes have problems with. Oftentimes people miss. Those are the most common. Most of the others are pretty self-explanatory. More than means adding, etc., sum, etc., etc. So let's take and write a couple of algebraic expressions from the verbal command. So here's that first case, of. Of is a term for multiplication. When I say 3/5, that's like a fraction. So 3/5 of means multiply W. Now I can write these two together. I could say 3/5 times W. This dot is what we're going to use for multiply now rather than the cross, or the X that you used in Algebra 2. When I say 9 less than a number P, well, 9 less means if I had 10 and I have 9 less, then I have 1. So we're subtracting 9 from that number P. So I have P minus 9. 8 plus the product of 7 and H. So here is my product, 7 and H. So if I have a product, that means a multiplication of 7 and H. And then I'm going to add to that because it says 8 plus. I'm going to add 8 to that. This last one's a little bit more tricky. It says twice the sum of a number and 3. Well, the sum of a number and 3 is written as x plus 3. And it said twice that. So this is 2 times that quantity of that number and 3. So now we've got some word problems. It says Mr. Allenbaugh buys 2 adult tickets and 3 student tickets for the game, and we want to write an algebraic expression that represents the cost of the tickets. If the student tickets are worth S dollars and the adult tickets are worth A dollars. So in this case, what we want to do is think about a real world application of this, even though there are no numbers in here. Let's say I had the adult tickets were $5 a pop, and the student tickets were $2 a pop, and I wanted to know how much money I made. Well, I'd take $5 times however many adult tickets I sold, right? And then I would take $2 for every student tickets I've sold. Now, that's a real world application, makes sense. In this case, the problem is asked the exact opposite of the example I gave you. It says you have 2 adult tickets, and we don't know their cost. But if I multiply those 2 tickets by the cost, which is A, I get its total dollar value. If I take and use 3 student tickets and multiply by the cost for each ticket, S, that gets me its total cost. So 2A plus 3S gets me the total cost. Now, next problem, it says Tyler's yearly salary 2 years from now. If his present salary is $32,000 and his salary is going to increase $2,300 a year. So right now, regardless, he's making $32,000. Now next year he's going to make more than that. He's going to make $2,300 more. So I could add $2,300 for as many years as I have, but I don't know how many years I have. I have T years. So if I add $2,300 once, that's for 1 year. If I do it twice, that's for 2 years. If I do it 3 times, that's for 3 years, and ever and ever and ever and ever. Now, instead of adding 2,300 3 times for 3 years, I could just multiply 2,300 by 3. Since we don't know our total number of years, I can multiply my 2,300 by T years, and this will be my salary after T years. Finally, the product of 2 numbers, if one is 8 more than the other. Well, the way I like to do these is I say number 1 and number 2. And I don't know either one of them. So I'm going to say number 1 is the unknown. I'm going to call it N for number 1. But I know the second number is 8 more than this guy. Well, to say 8 more than N is N plus 8. And it says find the product of these 2 numbers. Well, if this is the first number and this is the second number, and I'm talking about a product, I'm going to multiply those 2 quantities together. So N times the quantity of N plus 8 is going to be my answer. Next, you got to read this problem carefully to understand what they're asking for. The difference between the high and low tides on the Maine coast in November is 19 feet on Monday, and it's X feet on Tuesday. And they want you to write an expression that shows the average rise and fall. Well, rise and fall means difference, first of all. All right, so that's right here for Monday and Tuesday. Now, the word average, once again, means add up all your numbers and divide by the total number of numbers. Well, we're talking about 2 days of rise and fall. Okay, and on the first day, Monday, we get a 19-foot difference or drop between the 2. We don't know the amount on Tuesday, but we would have to add those 2 together to get an average. And since I only have 2 terms, I'm dividing by 2. So this expression, 19 plus x divided by 2, and if I wanted to, I could put the 19 plus x in parentheses, but I don't have to, is going to give me the average rise and fall.